Hey guys, welcome back again to the channel. So today we will be going through a concept that is known as scaling in machine learning. The scaling of vectors, the scaling of the data is very important whenever we are dealing with the data in machine learning, or whenever we are dealing with data that is whenever we have to work with the deep learning. So the scaling is very important concept in machine learning. So what is scaling? So let me first answer this question in a very simple way. Scaling is whenever you have the input data and output data, and the data, one data is on one scale and the other data is on another scale. Say suppose you have age of the employees as being from say 30 to 40 years, and then the salary of the employees is from 20 lakh to 50 lakhs. So this is the scale that is different for input variable and different for output variable. So in these terms, in these conditions, there is a chance that the machine learning model, deep learning model, will not generalize the model very well. So in such situations, what we do, we scale the data to a specific scale. So for those purposes, we use the scalars that are present in this Sklearn's pre-processing module. So in this lecture, in this topic, we will be going through the three basic scalars that are present in pre-processing module. One is the standard scalar, the another is the min-max scalar, and the third is the robust scalar. So we will see the implementation of these three scalars in this chapter, and hopefully from next chapter onwards, we will use these scalars whenever we have this different range, different scale of data present in our data set. So let's begin. As you can see, I have the path variable in my environment, and I have included this path because this is the data set we will be going to use. This is the same data set which we used in our previous examples. So say suppose we have this path, and now we need to import basic libraries that we will be working on, since we do not have any NumPy operations in this thing, but still we will import that NumPy just to be safe. So we will say import NumPy as NP and import pandas as PD, and then what we will do is we will read the data that is in that path. So what we will say data is equal to pd dot read underscore CSV, which is for reading the CSV files, and we will give it the path. And if we will say get us the data dot head, which prints the first 5 elements of the data set, first 5 rows, we can see that we got an error because it is saying that this data does not vary, this path does not exist. It is because I forgot to mount my drive. So let's do that first. So now we have mounted the drive. Now let's run this line of code, this cell again. We can see now that the data that is present in the CSV file is now in our data frame. So as you can see, we have 3 columns: position, level, and salary. What we need only 2 columns. For input, we will be needing level column, and this for output column, we will be needing salary column, because we do not need to do any kind of model training, etc. So we will be just seeing how to scale the data when we have this type of varying scale. So first of all, we will see what we will see, we will get this input and output data in different variables. See, we will say x is equal to data.ilog. It's the same function that we used previously. Get us all the rows, first colon, get us all the rows, and get us the first row up to the last row. First column, get up to the last column, dot values. And in the same way, we will say y is equal to data.ilog, get us all the columns, and get us all the rows, first colon, and then get us the last column, and we will say dot values. And what dot values does, it converts this array, this values into the NumPy array. But first of all, let's do one more thing. We need to reshape the y array. It is necessary in the model training, because it is necessary in the model training, but to be safe here, we will just train it, we will just reshape it. Sorry, not to train, we will just reshape it. We will say y is equal to y dot reshape. So what we, if no, now before reshaping, if I will see what is in my y, you can see that there is a row vector. So it is a complete row rather than a column, because if we see what is in our x vector, we will see there is the first row, second row, third row in this way. But if the y is in the same row, so what we need to do, we need to represent this y in this form. So now let's do that. So we will say y is equal to y dot reshape, y dot reshape. What we will say, the first is the number of rows. How many rows we want? We want the number of rows as the length of y, which is currently the number of elements in the y. And then we want the number of columns. How many columns do we want? We want one column. So if we do this and we will print y, we will see that y is now in the same form as it was in the as is the x. So now let us do one more thing. Since we know that for x it's 1, 2, 3, it's that scale, and for y it is a scale in say 45k to I think it's 100k somewhere. So that is the reason we do scaling. So the first scalar is that is known as a standard scalar. The problem with the standard scalar is that if we have outliers in our data, that is, outlier is a data entry that is far from the rest of the data, which makes the data skewed towards one end. For example, if we are computing the mean, we will get, if we are computing the median and mean, those try to be towards that larger values, larger one single value, two values, or three values, so that whole data set becomes skewed towards that one outlier or two outlier. So this is the first one disadvantage with the standard scalar, but it's very important scalar and we use it very often. So what is in this scalar, how do we perform scaling on this kind of data? So first of all, we need to import it. So we will say from sklearn dot pre-processing, because it's in the pre-processing module, we will say import standard scalar. We will say standard scalar, and then when we have imported the standard scalar, we need to create an instance of the standard scalar. So we will say xscale for the purpose of scaling x features. We will say xscale is equal to standard scalar, and we will run this cell. Now as we have run this cell, it means I have created the instance of this class, instance of this standard scalar. Now the thing is that I have created a box. Now I have to take my data and put it in the box so that that data becomes fits in that box. So this is the thing. Next thing we have to do, we have three ways in which we can do. First, we can fit the data, we can fit the scale onto the data and then transform our data according to this scale, or we can say directly say xscale perform the scaling operation on our data, and in the same function we will say transform the same data that is present. So we will say scaled data, we will say scale data, and we will say that xscale so we will say xscale dot fit transform. The same function which we use to train the model is fit model. So here we can separately use fit model and then transform function, but we will do in the same function. We will say fit transform and then give it our variable. So what does it do? It fits the data into this the box that we created and then transforms the same data according to that box, according to the rules in that box. So if we do that, and now if we print xscale data, we will see the scale of the data has been changed. Now it says an error because xscaled is not defined because it's xscaled data. Now let's run this. If we will see, their scale of the data has been changed. Previously it was 1, 2, 3, 4 and 5, 6 up to 10, and now it's minus 1.5 to 1.5. So the range of this standard scalar is somewhere between 3 to 3 or say 2 to 2. I don't remember precisely, but it's between this range, and every data that is being converted in this. Now the property of this data, of this scalar, is that it scales the data in such a way that the total mean of the data becomes 0, and the total variance in this data becomes 1. So the total variance is 1 and total mean is 0. This is the property of this standard scalar. Now the thing is, let's try to scale the y variable. So we will create another instance, another scale for the y variable. We will say y scale is equal to standard scalar, and then we will say y scaled data is equal to y scale, the same way we did for x, is to fit transform, and what we want to fit and transform, we want the y value to be fitted and transformed, and then we can say get us the scale data, y scale data, and we will see that now the data for y variable has been scaled, has been changed, and this time the range has been set from minus 0.72 to 2.6. So the range is somewhere between 3 and minus 3. Now the thing is that we have converted the data to what? To the new scale that we have prescribed. Now the thing is, how can we get the previous data, the data without a scale? Suppose we want to predict the data. If we want to predict the data, we have to first convert the input that data we are giving to the scale data according to the scale. Now after getting the output, we will get the output as per this new scale. So we have to convert that output back to our scale that was originally on our data. So how can we do that? So there is a method with every scalar method. There is a method known as inverse transform method. So what we can do is say the data that we have converted, apply the inverse transform method on this data and get us the previous data. So we can say x original org, x original is equal to, for x we use the scale x scale, x scale. So we will say x scale, SCALE, x scale dot inverse transform. So we will inverse transform. What do we want to inverse transform is the data that we have transformed. What is the data that we have transformed on the x scale, using the x scale, that is x scale data. And now if we will print this x original, we can see that it's same as the first original data. So as you can see, now same thing can be done to the y variable that we have converted using the y scale. So we can say yorg is equal to y scale dot inverse transform. And what do we want to inverse transform using the y scale? The data that was transformed using the y scale. What was the data that was transformed the y scale? It was the y scaled data. Y scaled data. And if now we print y original, we can see that it is same as the previous data, as the original data that we converted to using this scale. So in this way we convert the data using the standard scalar, and why the mean of the data becomes 0 and the standard deviation, that's variance, becomes 1.